Hello again. In this video, we're going to go over section R4, Objective 4, which is about simplifying special case products. So in the last video, we talked about how to multiply a binomial by a binomial using the FOIL method. And so what we're going to do in this video is we're going to look at special cases that can occur under the FOIL method. Okay, so the first one we're going to look at is what happens when you take the binomial a minus b and multiply it by its conjugate, which is a plus b. Now these are called conjugates of each other because they differ by a minus sign in front of the b term. So those are known as conjugates. And so what we're going to do is we're going to take the product of those two conjugates and see what happens under the FOIL method. Okay, so let's take a minus b and multiply it by its conjugate, a plus b, using the FOIL method. So the FOIL method, first, outer, inner, last. So the first would be a times a, which of course is a squared. The outer would be a times b, which is ab. And then the inner is minus b times a. And the order in which you write the a and the b doesn't matter. So you can write that as minus ab. And then the last would be negative b times positive b, which is negative b squared. Now notice the ab term cancels here. You have a positive ab and then a minus ab, so those cancel to 0. And then you're just left with a squared minus b squared. And that's called the difference of squares. So when you take the product of two conjugates, you end up with the difference of two squares. Okay, so that's the first special case that we're looking at. Okay, the next special case we're going to look at is what happens when you multiply a plus b by a plus b. So the signs don't change here, they remain the same. Okay, so let's see what happens here when we FOIL. So you get first, a times a is a squared. Outer would be a times b, ab. And then inner would be ba, which you can write as ab. Again, the order in which you multiply doesn't matter. And then the last would be b times b, which is b squared. And then notice this middle term, you have two of these ab's, so you can write it as 2ab. And so you end up with what's called a perfect square trinomial, a squared plus 2ab plus b squared. Now, it could be that both of these are minus signs. And so if you FOIL this out, let's see what you get. So first would be a times a squared. Outer would be a times minus b, which is minus ab. And then the inner would be minus b times a, which is minus ba, but you can write that as minus ab, switching the order of multiplication. And then the last term would be minus b times minus b. So a minus times a minus is a plus, of course, and so you just get plus b squared. And then the middle term would add up to negative 2ab, because those are like terms. And so you end up with another perfect square trinomial. But notice the difference between these two is this middle term has a minus sign in it, whereas this one has a plus sign. Okay, so these are the special cases that we're looking at. The product of conjugates. So when you take a plus b and multiply by a minus b, that's called the product of conjugates. Or the square of a binomial, when you take a plus b and multiply it by a plus b. Another way to write that, of course, is to just write it as a plus b squared. And then the other square of a binomial would be a minus b times a minus b, which can be written as a minus b squared. Okay, so let's just try some of these. I'm going to go through some of these special cases. Okay, so let's multiply this out. Now, I'm not a big proponent of you necessarily memorizing those special cases. If I were given this problem, I would simply just FOIL it out. So I think if you just think of this as using the FOIL method, you don't really need to think of it as a special case. Although I think you should be aware of these special cases. And so being aware of the special case, I do recognize that these are conjugates of each other. So this should fall under a situation where we end up with the difference of squares. But let's just FOIL it out and see what happens. Okay, so the first would be 2x times 2x. The outer would be 2x times minus 5, which is minus 10x. The inner would be 5 times 2x, which would be positive 10x. And then the last would be 5 times negative 5, which is minus 25. And so notice the middle term does cancel. And then this first term here will be 4 times x squared. Remember, you can move the 2 in front and multiply it by this 2, and then multiply the x's together. So the order in which you multiply doesn't matter. And so you end up with 4x squared. The middle term cancels, and then minus 25. Now this really is the difference of squares. You can write this using the special case formula. This would be a squared minus b squared. Now again, I'm not necessarily a big proponent of memorizing this. I would simply FOIL this out. But let's just see if this formula would work. First of all, let's look at what a and b are. So a is the 2x, and the b is equal to the 5. Okay, so in our little formula, we would get 2x squared minus 5 squared. And I think you can see that that is, when you square this, you end up with 4x squared minus 25. So using the formula, we would get the same answer. But again, I'm just a proponent of not necessarily memorizing the formula. I would just FOIL this out, and that's what ends up happening. Okay, so I want to look at part B here. So let's take 1/3 c squared minus 1/2 d and we're going to multiply that by its conjugate, which of course is 1/3 c squared plus 1/2 d. Now again, I'm just going to FOIL this out, but then we can go back and look at the formula and see if we get the same answer. Okay, so the first would be 1/3 c squared times 1/3 c squared. All right, outer would be 1/3 c squared times 1/2 d. All right, the inner would be minus 1/2 d times 1/3 c squared. And then the last would be minus 1/2 d times a positive 1/2 d. Okay, so let's see if we can't simplify this. Again, the order in which you multiply doesn't matter, so I can take the 1/3 and multiply it by the 1/3 in front and get 1/9. And then c squared times c squared would be c to the 4th, adding exponents. Now notice here, these would cancel out because you have 1/3 c squared times 1/2 d, and then over here you have the same thing except it has a minus sign in front of it. In fact, if you wanted to, when you add a negative, that's the same as subtracting, right? So you can think of this as subtracting all of this. which is going to cancel with this term. So those cancel out. Okay, and then the last term here, you're multiplying a negative 1/2 by a positive 1/2, and then multiplying a d by a d. Okay, and so this is going to give you negative 1/4 times d squared. And of course, when you add a negative, you can write that as subtraction. Okay, so that's what you end up with when you FOIL this out. Now, let's go back and use the formula and see if we get the same answer. So in this case, A is the 1/3 c squared, and the B is 1/2 d. Now notice the B is the number that follows this minus sign. So the thing that follows this minus sign is 1/2 d. Okay? B is not negative 1/2 d. This negative sign and this negative sign are the same. So B is the number that follows this minus sign. So B is positive 1/2 d. Okay? And now let's just plug that into our formula. And let's see what we get. So it's a squared, well that's a, so that a squared minus b squared. And then when you square this, you can square each of these terms individually. And you can square each of these individually. Okay, and so 1/3 squared is just 1/3 times 1/3, and that's 1/9. Here you multiply exponents, so you get c to the 4th. And then here 1/2 times 1/2 is 1/4, and then d squared. And so you can see you do end up with the same answer if you use this little formula. Okay. Okay, so now let's look at example 4, part A and B. Now here we're not multiplying by conjugates. This is the square of the binomial, which is, when you write this out, when you square something, it means you multiply it by itself. So this means 3x minus 7 times 3x minus 7. A very common mistake that people make is to simply square the 3x and then subtract 7 squared. But that's not what this means. This means 3x minus 7 times 3x minus 7. So we actually have to FOIL this out. Okay, it's incorrect to simply say that it's equal to this. Okay, so be careful not to make that mistake. This is wrong. You actually have to FOIL this out. So let's see what we get. First would be 3x times 3x. Outer would be 3x times minus 7, which is negative 21x. The inner would be negative 7 times 3x, which is also negative 21x. And then the outer would be negative 7 times negative 7, which is positive 49. And then again, the order in which you multiply doesn't matter, so you can just say 3 times 3, which is 9, and then x times x, which is x squared. And then here, these add up, because they're like terms. So you end up with negative 42x plus 49. Now notice if you made this mistake over here, you would end up with 9x squared minus 49. And again, this is incorrect, right? This is wrong because you're missing this middle term. Okay, so you can't just square this and then subtract this squared. That doesn't work. Okay, and if you happen to use the formula, a minus b times a minus b is a squared minus 2ab plus b squared. Of course, a is 3b, a is 3x, but the b is positive 7. Again, b is the number that follows this minus sign, and a positive 7 is what follows that minus sign. So b is positive 7. Okay, so if you just plug this in, you get 3x squared minus 2 times 3x times 7 plus 7 squared. And of course, this gives you 9x squared. This gives you 2 times 3 is 6, and then 6 times 7 is 42. So 42x. And again, you can change the order of multiplication there. And then 7 squared is just 49. And so you end up with the same answer. Okay, so let's try this one. The difference here is that this is a plus sign, but we're still squaring this binomial. Okay, and again, you do not square this first term and then add it to the second term squared. That's incorrect. You have to FOIL this out. So again, when you square this, it means you multiply it by itself. Okay, which is really this. So let's FOIL this out. So the first would be 25, and then you add exponents, t to the fourth. Outer would be 10 t squared times v squared. The inner would be 10 v squared times t squared, but the order doesn't matter, so I'm going to write it as t squared v squared. So it matches this order. And then the last would be 2v times 2v, so 4, and then you would add exponents, so it would be v to the fourth. Okay, and then we can add these two like terms together. There's actually 20 of these t squared v squared terms. Okay? And so that's what you get when you square this binomial. Now again, it is wrong to say that it's simply this squared plus this squared. Okay, this is wrong. And you can see why, because here you would get 25t to the fourth plus 4v to the fourth. And again, you're missing this middle term. Okay, so be careful not to do that. Okay, and then if you wanted to use the formula, so a plus b times a plus b is a squared plus 2ab plus b squared. Now in this case, a is 5t squared, and b is 2v squared. And then you could just plug these in. So a squared plus, so a squared would be 5t squared, right? Squared. Okay? A is 5t squared, and you're squaring that. Okay? Times 2a, which is 5t squared, and then b is 2v squared, plus b squared, and this is b. So 2v squared squared. Okay, and then you go through and square this, and of course you get 25t to the fourth. And then when you multiply this up, again, changing the order of multiplication, so 2 times 5 times 2 would be 20. And then t squared times v squared. And then here you get 4v to the fourth. And so you do end up with the same answer using the formula. Okay. So the last thing I want to look at is sort of some applications of this. When might we get some of these special cases in the real world? So a lot of times you get these special cases when you have something like, here we're trying to write a polynomial that represents the area of this rectangle. Now this side of the rectangle has a length of x plus y plus z squared, whereas this side has a length of x plus y minus z squared. And so let's find the area of this rectangle. Okay, so area, of course, is length times width. Okay, so let's take the length of this. The length is x plus y plus z squared. That's the length. And we're going to multiply it by the width. And if you remember, the width is x plus y minus z squared. Okay, so you could either FOIL this out, since it's a binomial times a binomial, or you could recognize that it's the difference of, or that you're multiplying two conjugates together, and so you'll end up with the difference of two squares. So I'm just going to FOIL this out, and if you want, you can check it using the formula for multiplying two conjugates together. But I'm going to call this the first term. So when I say first, outer, inner, last, the first is x plus y times x plus y. Okay, so that's the first. Now the outer would be x plus y times negative z squared. And when you multiply those together, you're going to get a negative because it's a positive times a negative. So it's negative, and then it's x plus y times z squared. Okay, and now the inner would be this times this. So it's going to be a plus because you have a plus here and a plus here. So it's plus z squared times x plus y. And then we'll change the order of this because the order doesn't matter. And if we change the order, it'll look like this, except it'll be a plus sign instead of a minus sign. So those are going to cancel out. All right, and then last would be this times this. And notice you're going to get a negative because it's a plus times a negative. So it's negative, and then z squared times z squared, you would add exponents, and it's going to be z to the fourth. Okay? And then let's switch the order here. The order in which you multiply doesn't matter. So I'm going to put the x plus y first, and then multiply it by the z squared. And that makes it clear that these two cancel out. This one's negative and this one's positive, so they cancel out. Okay, and so then you're left with x plus y times x plus y minus z to the fourth power. And then you can actually FOIL this out unto itself. So let's FOIL this out. So first would be x times x, x squared. Outer would be x times y. Inner would be y times x, but I'm going to write that in the order of x times y. The order doesn't matter. And then the last would be y times y, y squared, and then minus z to the fourth. And then notice here you can add these up because these are like terms, so that's really 2xy. Okay, so that's what you get when you multiply these two conjugates. Now, if you wanted to use the formula, A would be x plus y, and B would be z squared. And then you would just use the formula a plus b times a minus b is equal to a squared minus b squared. And you would just plug those in. A is x plus y, so you get x plus y squared, and then b is z squared, so you get z squared squared. And again, so the x plus y squared is this part, right? That's the same as x plus y squared minus z to the fourth. So you're getting the same answer. And when you FOIL this out, right, we already know that you end up with this. So you do get the same answer. And this is z to the fourth because you multiply exponents. Okay, so using the formula, you would get the same answer. Okay, last thing, let's look at part B. Okay, so I think I've lost the page, but let me see if I can't pull it back up. Okay, so part B for example 5, they want us to write a polynomial that represents the volume of this cube. And of course, the volume of a cube would be length times width times height. And so here you just multiply x plus 3 by x plus 3 by x plus 3. Okay, so let's see what we get when we do that. Okay, so the volume of a three-dimensional cube or object like that would be length times width times height. And in this case, the length was x plus 3, the width was x plus 3, and the height was x plus 3. Okay, so what I'm going to do here is we're going to first multiply these two binomials together. And then when we're done, we'll multiply by this one. So let's take care of these two first. Okay, so to multiply these together, you're going to have to FOIL it out. So you do first x times x, which is x squared, outer, which is x times 3. But I'm going to change the order and write it as 3 times x. So that's your outer. And then that's your outer, right? X times 3, but I'm writing it as 3 times x. And now your inner is 3x, right? 3 times x. And then your last would be the 3 times the 3, which is 9. Okay, and so you end up, and of course, like I said, this x plus 3 sits out front. Okay, and then we'll multiply this by this binomial later. Okay, so inside here we have x squared And this adds up to 6x, so plus 6x plus 9. And then now I'm going to multiply by this x plus 3 that sits on the outside of all that. Okay? Now, to multiply these out, we're going to do something very similar to foiling. We're going to distribute this x plus 3 to all three of those terms. All right, so you get x plus 3 times x squared, x plus 3 times 6x, and you get x plus 3 times 9. And then we can distribute this x squared to both of those terms, okay? So you get x cubed plus 3x squared. Here you get 6x squared, and then 18x. And here you get 9x plus 27. Now remember, you can also do this by taking this x and multiplying it by all three of those terms, and then taking the 3 and multiplying it by all three of those same terms. And you'll get 6 different terms, just like I did here. You'll get the same 6 terms as you do here. So you could also do it that way. Okay, but either way that you do it, you end up with this. And now let's just add up like terms. So these add up. So you get x cubed plus 9x squared. And then you can add these two together. And that gives you 27x plus 27. Okay, so that's what you get when you multiply those together. Now, you could have multiplied, just so you know, you could have multiplied these together from the very beginning using the formula for what you get when you square a binomial, a plus b times a plus b. Okay, you get a squared plus 2ab plus b squared. And in this case, a would have been x, and b would have been 3. And I think you can see you're going to end up with x squared plus 2 times x times 3 plus 3 squared. And remember, the order in which you multiply this doesn't matter. So I can move the 3 in front and multiply it by the 2, and I'll get 6x. And so that's exactly what you got here. Okay, so you could have used that formula to do that. But then once you got to this point here, however you got to this x squared plus 6x plus 9, whether you FOIL it out or you use the formula, then you would have to go through and multiply x plus 3 times x squared plus 6x plus 9. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.